Hello guys and welcome. I hope that you're having a good day or good morning or good evening. My name is I play 4K, aka I play 8K, aka I play 16K or UHD King. During this video today, I'm going to show you Doom 3 BFG PC game running on 16K resolution rendered in real time, or 133 megapixels rendered in real time. So how I achieve that? I'm using 8K resolution native screen plus Nvidia DSR method. I'm not using any third-party DSR methods. I'm using the Nvidia DSR method. Nvidia driver is hacked, so I'm recording this video with Nvidia shadow play technology. So this is also hacked, and I'm recording in 8K resolution through the system RAM debugging tool. I hacked the width and height values as well, so instead of 4K resolution, it allows us to record 8K resolution, and Titan RTX has no problem to record 8K resolution through the Nvidia shadow play at 60 FPS. Keep that in mind. So let me real quick go ahead and show you, first of all, that my desktop, as you can see, is set at 16K resolution. Let me go ahead and show it to you as a proof. Okay, I'm going to use the Windows magnifier tool. Keep in mind that I'm not going to edit this video. This video will be uploaded in 8K resolution to the YouTube. So go ahead and please to watch for the best possible visual experience. You want to watch it in 8K resolution, but 4K resolution as at least. So 15,360 pixels by 8,640 pixels. Which is the 16K resolution or 133 megapixels. The scaling resolution will be at 100%. This is exactly what you want to do if you're running some games in a windowed or windowed full screen mode, borderless mode. Keep that in mind. 100% scale is very important. Okay, let me real quick go ahead and show you about my system, and we're going to jump into the game. So this is what's up. Today I'm using the Xeon E5 2697V2 CPU. It's going to be on my workstation. It's not my gaming PC. I'm also going to show you on my gaming PC, but let's go ahead and have a look how Titan RTX performed with the CPU from 2013. The Intel Xeon E5 2697V2 CPU was the enterprise CPU from 2013-2014. It used to cost $2,500 US. I purchased it in 2020 for $129 for my workstation to render videos, to encode some videos, and do some 3D rendering as well. A lot of 3D rendering video tutorials are coming to the UHD King YouTube channel when I'm going to teach you graphics design, 3D rendering, and stuff like that. It's going to be amazing tutorials. Don't miss out. So what happened here, this CPU is 12 cores. With the hyper threading technology, it becomes 24 virtual cores in the Windows 10, or 24 threads, whatever you want to call it. So but this CPU has locked multipliers. They do not allow you to overclock the CPU. During the 2013 CPU with 24 virtual cores under the Windows was like, wow, mind-blowing. It was so fast and so amazing. So they locked the multiplier. Intel locked the multiplier. Do not allow you to overclock the CPU at all. But there is some cheating here. When the CPU is running 4 core 4 threads, it boosting up its multiplier to 30, I believe 32, yeah, 32 multiplier, and it becomes 3.4 gigahertz with this overclock. As again, I overclock it a little bit. I will explain to you how I did it. When I'm running at just 3 core 3 threads instead of 4 core 4 threads, it's boosting up to 3.5 gigahertz or 3500 megahertz per each core per each thread automatically, like kind of automatic overclocking, turbo boosting. When it's running 2 cores, it's running 3.6 gigahertz or 3600 megahertz. But unfortunately, Doom 3 BFG game in 16K resolution not possible to run without losing any FPS with 2 core 2 threads. I'm going to explain to you during the gameplay, during our benchmark. And when you're running 1 core 1 thread, it's boosting up to 3.8 gigahertz with my method of the overclocking, kind of cheating overclocking. How I overclock it, guys? See that bus speed? Let me zoom in a little bit more. That bus speed, the bus speed is BCLK, and today I'm using the gaming Gigabyte X79 motherboard, UD3 version 1.1 that I was using back in 2013-2014 when I was running 4 Radeon R9 290 in Crossfire and 4 Titan X Maxwell GPU architecture in 2016, and I was using the i7 Core i7 4930K CPU overclocked to 4.2 GHz stable on this motherboard, but that CPU was just 6 cores, 12 threads, and I double amount of my threads with this CPU, and this is exactly what I'm looking for the video encoding and 3D rendering. So this is a workstation, but let's go ahead and have a look how it's going to perform as a workstation CPU with the Titan RTX. I'm going to prove you some points if you're a beginner gamer, how to properly build yourself a gaming PC if you're into the gaming PC, and or how to build the overall PC. So let's say if you're doing some 3D rendering, video encoding, playing some games, this is the best way to go. And I'm going to explain to you why during our gameplay in a second. But anyways, how I did it. So bus speed, it says 106 megahertz, 105.99, so 106 megahertz. Usually it's running 100 megahertz. So I overclocked BCLK bus speed by 6 additional megahertz, and it brought us additionally 200 megahertz boost. Additionally, no matter how many multipliers you're running, no matter how many cores you're running, additional 200 megahertz boost, okay, versus the stock. Already receiving 200 megahertz boost on top. Plus, I boosted up from 2.8 to 3.4 with 3 cores, 3 threads, because as again during this game I know for sure we're not going to utilize our CPU above 90%. That means that we don't need additional threads or additional cores, and but frequency is very important, keep that in mind, and I'm looking for the 3.5 gigahertz frequency versus the 3.2 gigahertz when I'm running 12 cores, 24 threads. And you want to shut down the hyper-threading technology when you're playing some games, because the hyper-threading technology is 3.5 times slower than the physical cores. Those type of virtual cores is 3.5. Those 3.5 virtual cores will be equal to 1 physical core, keep that in mind. And I decided to keep only the physical cores to eliminate any latency delay and keep it as fast as possible. Hopefully guys this makes sense. My strategies, the algorithms that I use, I'm just explaining to you as PC overclocker, PC hardware enthusiast, a system engineer. So the motherboard is again Gigabyte X79 UD3. This is version 1.1. They have version 1.0, and this is the later version 1.1. Only with BIOS F20 is possible to run this CPU from March 19, 2014, available from the Gigabyte website. You want to flash it probably with the i7. I used my i7 4930K, because if you're going to install the CPU, it's not going to boot up, it's not going to post, keep that in mind. My Titan RTX running 16X, as you can see on PCI lanes version 3.0. I can install 4 video cards running times 8 or 2 video cards running times 16 PCI lanes per each video card. Okay, memory is quad channel, means 256-bit instead of dual channel, which is 128-bit. Theoretically, it's gonna boost up 2 times versus the dual channel, but in practice, it's 1.3, 1.4 times faster than dual channel. Keep that in mind. So I'm running total 32 gigabytes of DDR3. This motherboard is only accepting DDR3, as again I just use the spare parts and I just upgraded my system. This is a great CPU if you're looking to upgrade your system when you're already having the X79 motherboard laying around, some DDR3 memory. This is a great processor to go, the great CPU, right? Especially for the workstation or 3D rendering firm, and exactly as I'm using it today. 32 gigabytes, which means 4 sticks of 8 gigabytes of system RAM. Okay, this is going to be Crucial Ballistics 1866 megahertz CL9, but unfortunately on this particular CPU it's not stable above 1400 megahertz, and even 1400 megahertz is going to blue screen after 30-45 minutes. It's random blue screen. So the completely stock and stable frequencies will be 1130 megahertz, which is 565 megahertz times 2, 1130 megahertz. Same scenario will be for the V3 CPU, only the V3 CPU going to use the DDR4, and it cannot go above 1200 megahertz on the DDR4. Those type of heavy multi-core CPUs from enterprise version CPUs, V2 and V3, is kinda don't like the high frequencies DDR3 or DDR4 memory. Keep that in mind. DDR4 high frequency memory will be kind of okay idea for the V4 CPUs, but as again, you cannot push it as harder as you can overclock the frequency on a DDR3 or DDR4 as you're using your gaming rack, your gaming CPUs. Those enterprise CPUs very picky about it. So I decided to use CL7, which boosted up in terms of my latency delays. Over here, as you can see, IDA cache memory benchmark. So when I'm using CL9, it's above 100 nanoseconds latency delay. When I'm using the CL7, it's 93, below 94 nanoseconds latency delay, so about 6-7 nanoseconds faster in terms of the latency delay. The lower value in terms of the latency delay, milliseconds or nanoseconds, that you're going to see during this benchmark is better. The higher FPS is better. Okay, so 1T command. All right, so believe me or not, but this DDR3 quad channel is fast as DDR4 2133 megahertz CL18. It's faster in terms over here, read, write, and copy. Okay, or kind of similar, equal to. Okay, so graphics, as you can see, Titan RTX right now running stock. The memory, which is DDR6, is running 7000 megahertz. I'm about to overclock it additional by 1000 megahertz for free. It's going to be 8000 megahertz times 2, 16,000 megahertz output out of our GDR6, and 24 gigabytes by Samsung, same memory that they're using on RTX 2080 Ti. Unfortunately, RTX 2080 Ti only have 11 gigabytes of GDR6, and Titan RTX has 24 gigabytes of, which is double. And this is the first video card that allow us to run a lot of old school games at 16K resolution. Keep that in mind. And those 16K resolution, even when we're using DSR and downscaling to 8K resolution, I can see the difference in terms of the pixel density. Keep that in mind when I'm physically with my eyes comparing 8K resolution to 8K resolution versus the 16K resolution downscale to 8K resolution. I can see that 16K resolution downscale to 8K resolution looks on another level, and it's much better. The pixel density is right on, guys, those details. Okay, this is how it benched. As you can see, as again, it doesn't see the 3 cores under the CPU Z. It doesn't see the 5 cores as well, so it's kind of 1 core, 2 core, 4 core, 6 core, 8 cores, and etc. Right? But it doesn't see those numbers, 3 or 5 or 7 cores. But it doesn't matter. In games, we're going to utilize it. Windows still going to see that. Okay. So pretty much that's it, guys. And this is how IDA64 GPU benchmark score in OpenCL. In OpenCL API, we can kind of bench GPU and CPU and compare the results. Okay, and over here, when I'm going to overclock the video card in a second, my pixel fill rate ratio right now is 169. I mean, value is 169.9 gigapixels. Textual fill rate value is 109 gigatexels, and bandwidth is 672 gigabytes per second. Keep that in mind. This values will be increased immediately. Let me go ahead and do that. Guys, I'm coming in real time. You're probably going to hear a little bit of noise in the background. As again, I'm not using the RTX audio application that canceling completely noise by the AI, but it's still utilizing some video card resources, and it's going to drop our FPS by 5 FPS, and I don't want to see that. We're already dropping our FPS by 4 FPS because I'm recording with Nvidia Shadowplay, so please add 4 FPS to the FPS counter during the gameplay. Alright, let me overclock it. You're probably going to hear a little bit of fan noise in the background. The case is a little bit open. I'm located in the same room. Dual fan on Titan RTX is kind of noisy. Keep that in mind when it's running 100% on a fan rotation, and it's running 100% on a fan rotation. I overclock my GPU by 100 megahertz additional and my VRAM by 1000 megahertz additional, which will be 2000 megahertz because GDR6, as you can see, it went from 14,000 megahertz to 16,000 megahertz. And over here under the graphics, we also overclock our memory from 7000 megahertz to 8000 megahertz, and the pixel fill rate is increased dramatically. Check it out, by 100 gigapixels per second pixel fill rate. Textual fill rate increased by 30 gigatexels per second, and bandwidth increased by about 80 gigabytes per second. The bandwidth is almost as fast as GDR6X on the RTX 3080, almost a hair slower than that. I believe the RTX 3080 is above 800 gigabytes per second, but we getting almost so much closer to that values. All right, guys. So this is what we're gonna do, and let's go ahead and have a look. Somebody, let me see. I think I got the delivery Xeon's E5 2699 V3. 1 second, guys. 1 second. Yeah, well, I'm not gonna open that because I'm recording right now and I'm trying to record without, but those guys, those CPUs are ready now. I got those CPU. I got, guys, the two Xeon E5 2699 V3 CPUs that I'm going to overclock because the V3 CPUs is overclockable. I just got them, and I got them for $129 per each, so $250 total from one local recycling company, e-recycling company. And I purchased myself the Chinese motherboard. It's going to be a great videos on that topic. It's going to be my rendering firm version 2.0 with the 72 virtual cores in the Windows, and it's going to be amazing. And I'm going to overclock them. I'm going to hack the BIOS. As again, tutorials on that system is coming, but let's go ahead and get going, guys. I showed you everything what you need to know. We overclocked that, and right now I'm just going to go ahead and launch the Doom. As again, keep in mind, guys, that I'm not going to edit this video. This is very important. The values at the right top corner, guys. My Steam window right there at the bottom right corner, just a tiny one. Hard to see. Look how small the mouse cursor right here. Alright, guys, so here we go. Doom 3 BFG. Okay, I'm going to start, and let me introduce you to a console real quick. Guys, I know this video is not going to be short. Go ahead and grab yourself a favorite drink. The best healthy drink will be water with the lemon, or get yourself a tea with the lemon. It's the best healthier drink you can ever drink. Tea with the lemon. Drink it for 2 months, and you're going to feel so healthy. You're going to clean your stomach, and it's amazing. Okay, so as you can see, it's full screen, but it doesn't say the resolution. Let me bring the console. I enabled the console in Steam. Go ahead and learn. It's allow console 1. Learn how to do it through the Google. You gotta do it, otherwise the console is not going to be enabled in the Doom 3 BFG by the default. You're gonna enable it in the Steam. I'm using the Steam version, but let me real quick go ahead and show you the custom width command, r_custom width command. As you can see, default is 1280, but I'm running 15,360. Nice. And our custom height 8,640 pixels. Guys, I cannot wait for those two Xeon E5 2699 V3 CPUs in my Chinese motherboard that will be hacked. Hopefully I'm going to hack them to 3.5 gigahertz, 72 threads. It's going to be mind-blowing. I think I'm going to beat the that Ryzen 5950, completely destroy it for just what, $250 for 2 CPUs, and with the $150 Chinese motherboard, and I'm going to utilize my spare DDR4 for it. So alright, guys, here we go. We got it, Houston, we got it. Let's go ahead and run it. This is going to be my second time running it on the Titan RTX, guys. And but it's going to run it. Look at this. You want to keep your eye at the right top corner. You want to keep your eye at the GPU utilization, which is 90% right now, 92%. You want to keep your eye at the VRAM utilization, which is 14,861 megabytes, so almost 15 gigabytes. So already RTX 2080 Ti video card cannot handle this, or it's going to handle this by offloading some data into the system RAM, and it's going to decrease the FPS dramatically. The system RAM value is 8,782 megabytes. The total system RAM value is, 32 gigabytes or 32,000 megabytes. And you can see the CPU utilization as well. When CPU utilization below 90% during the gameplay, means that we are not bottlenecking our CPU in terms of the CPU cores, and we don't need additional threads or additional cores. Keep that in mind. Otherwise, when it's going to be a lot 90% and above during your gameplay means that you need to add additional threads or additional cores just to enable it in the BIOS if your CPU is supporting more cores and threads, like in my scenario, or purchase yourself a better CPU with more cores or threads. Otherwise your FPS will be decreased by the Nvidia driver, OpenGL API in this case, or DirectX API, or Vulkan API, and by completely Windows operating system as well. This is pretty much, you know, logic and the algorithms that you gotta apply as the, you know, completely makes sense to anyone. So beautiful FPS, as you can see. The Titan RTX is again is overclocked. SLI is not supported in OpenGL API. So I cannot run two Titan RTXs, but when I'm going to play it on a gaming rig with my i9 9900K overclock at 5.3 gigahertz, I'm pretty sure that our FPS will boost up dramatically, just because the i9 9900K is 9000 series Intel CPU, 9 gen Intel CPU, and this Xeon is similar as 4 gen Intel gaming CPUs, and pretty much 5 more generation from this Xeon, and each generation, look how beautiful everything is. Of course the textures are so low quality, but it's amazing, guys, even with the low quality textures. Let me show it to you, something that you're not gonna see. Let me try to use the zoom tool, or Microsoft zoom tool doesn't work. Alright, Microsoft zoom tool doesn't work here. That's beautiful, especially when you work looking at the textures at the distance. Every single texture is rendered here. Look at this, every single details. So guys, the 9 gen Intel CPU will be 5 gen above of this CPU, and that means that pretty much the formula is easy. The next gen from the current gen is 3% boost, similar megahertz to megahertz on a CPU core. Okay, so 5 gen, 3 times 5, 15% additional boost, plus i9 9900K running 5.3 gigahertz with 6 cores, 6 threads. This is how I overclock that. This is how I'm playing games. That means that additional 2 gigahertz or 2000 megahertz per each core boost. So I would say we're going to be 20% higher in terms of our FPS, if I'm not mistaken. But it's nice to find out if my calculation is right or not. Just to watch that video when I'm going to record it to you. I'm going to record it to you probably in the end of 2020 or in the beginning of 2021. Guys, I'm wrapping up with Titan RTXs. I'm wrapping up with this Xeon E5 2697 V2 CPU. Then I'm going to wrap up with the Core i9 9900K CPU. And then I'm going to switch to RTX 3090s. Probably dual of them in SLI, and something better in terms of the CPU for the gaming station. And as again, you know, in 2021 I will switch to 2 Xeon E5 2699 V3 CPUs from 2014. Each CPU in 2014 was like $5,000, and I got them for $125 each, which is unbelievable. And pretty much $10,000 just for CPUs I got for $300, even below than 300, 250. Cannot wait to bench that system. And keep in mind that V3 CPU has some approach when you're going to hack the BIOS, and you can overclock them, even the enterprise CPU. But imagine to overclock total power of the 72 virtual cores in the Windows from 2.3, because they designed to run 2.3 gigahertz constantly. Those 72 cores at 2.3 probably is not going to be great in gaming, and even as workstation, when you're going to compare it to 3.5 or 3 gigahertz with 72 virtual cores. And this is exactly what I'm looking to achieve. I'm looking to achieve above 3000 megahertz per each core on all of those 72 cores, virtual cores in Windows, so 72 threads, whatever you want to call it, and maybe even higher than that. 3.5 will be amazing, and I believe when it's going to reach 3.5 gigahertz per each core, 72 virtual cores in Windows. I'm going to destroy the Ryzen 5950 like it's nothing. And Ryzen 5950 in the end of 2020 cost $900 on Amazon. They raised the prices because the demand is high and those CPUs are not available. Plus the motherboard will cost you another $200. And you know, it's expensive build comparing to two Xeon E5 2699 V3 CPUs. And when everything is, you know, depreciated, the value depreciated as hard as possible, and you're just gonna get it like nothing. And if I'm going to bid the Ryzen 5950 with the two Xeon's E5 2699 V3 CPUs, I'm going to be, guys, impressed and amazed, and I'm going to call it deal of the day as my workstation for 2021 for the video encoding. So I'm going to produce more 8K resolution videos for you. Wow, sorry about that. Looked like I was drinking water real quick and didn't do it right. Tried to sip it quick. And 3D rendering, video encoding, and my application that I'm developing, FFmpeg++, application which will utilize the FFmpeg library but will be available for any user, easy to use, will utilize above 128 cores on a CPU. So it's going to be nice to test it and see how fast I'm going to boost up video encoding 8K resolution to 8K resolution, 2697 V2 CPU versus the 2699 V3 CPUs, and see can I boost it up at least by 2 times with those two CPUs. And if it will be the case, it's going to be amazing, but we're going to find out. I'm going to also do a lot of benchmarks when I'm going to test just the CPUs, the V3, those two versus this one, and we're going to find out what is the value. Hopefully it's going to be by 2 times, because 2699 V3 CPU, each of them has 36 virtual cores or 36 threads with the 18 physical cores. Keep that in mind. Wow, it's running nice, guys. It's running nice. It's running faster than it's running 12 just a physical cores on the CPU with this 3-core 3 threads. So this is very important when you're running the games on the Xeon's E5s, guys. You wanna make sure the hyper threading technology is disabled if your BIOS is allowing to do that, and if you can unlock the turbo boost automatically, go ahead and do that by lowering your cores if your CPU utilization below 90%, and our CPU utilization below 90%, so we're not bottlenecking the FPS by CPU cores. Okay, that's it, guys. I showed you everything what you need to know. Hopefully, guys, you enjoyed that. It was a beautiful visuals. I really enjoyed that. Imagine to play it with the modes. You saw the VRAM utilization was below 16 gigabytes or below 16,000 megabytes. The system RAM utilization was below 9,000 megabytes. We had the healthy VRAM utilization, 16K resolution render, beautiful 133 megapixels in real time. Of course, downscaled, but it doesn't matter. Pretty much plus minus 2 FPS will be the same performance on the 16K resolution native resolution screens back in the future. I would say 2025, 2027. You just watch it in 2020, alright? This is the second video of Doom 3 BFG running 16K resolution. I also ran it on RTX 2080 Ti. Go ahead and check it out. But RTX 2080 Ti going to have probably the system RAM overload because it's going to offloading some data from the VRAM into the system RAM. So go ahead and watch that video. I'm going to include that video in the end of this video or in the video descriptions. Go ahead, guys, smash that like button, subscribe for more great videos, support me, and more great videos are coming. And I will see you guys in the next video. I cannot wait to test this game on the RTX 3090. Hopefully you're also going to enjoy it. And as again, I play 4K, AK I play AK, AK I play 16K, or UHD King. What with you today, I'm going to go ahead and unbox those Xeons, and I will see you guys till the next videos. Have a happy holidays, stay safe, till the next time.